Hello everyone, welcome to It's All About Education channel. So today we are going to learn a trick to remember trigonometric values. So trigonometric values are very important part in trigonometry. So here is the table for trigonometric values. This table has to be memorized compulsorily for the problems to be solved on trigonometry. Not only in your 10th standard and SSLC but also in your PUC level education. So it's very important to by heart all this, and to by heart all this, to memorize all this, it's very time seeking. You take a very long time by hearting these values, and sometimes you may also get confused with these values when you by heart too much. So today we are going to learn a simple trick to learn these trigonometric values in a very easy way. So let's start. So first of all, we need to consider our left hand, and we are going to assign these thetas. That's from 0 degree, from 0 degree to 90 degree. That is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So we are going to assign those values for our fingers here. So for thumb finger, it's 90 degree. For index finger, it's 60 degree. For middle finger, it's 45 degree. For ring finger, it's 30 degree. And for little finger it's 0 degree. So here a point which is to be noted is we will be using our left hand for this, not our right hand. So your left palm must be facing your face. Then you are going to give these theta. You are going to assign these values to your fingers. So your left palm must be facing your face, and you are going to assign all these thetas. So next, what we are going to do is, coming to our trick number 1, that is trick for sine theta. So for sine theta, what we are going to do is root of fingers below by 2. So suppose you have to find sine 60 degree, you think. So which is my 60 degree? It's index finger. I'm going to close that index finger. And how many fingers I'm having below? It's 3, right? So root 3 by 2 would be my sine 60 degree, and we can see here sine 60 is root 3 by 2. So the trick is very simple. So you have to fold the theta which is to be found. Like suppose we took the example of sine 60. Now let's take another example. Let's take example for sine 30 degree. So for sine 30 degree, so my ring finger is my 30 degree. So I'm going to fold my ring finger, and how many fingers are left below? Only 1. So that one finger we are going to consider. So root 1 by 2. Root 1 by 2 is nothing but my 1 by 2. So here we go. So sine 30 degrees, what my 1 by 2. And the rest are also the same. You can easily find them using this trick. So for sine, how do you remember that it's the root of fingers below only? So now this can make a problem. So there is a trick for that too. So sin. Now this is a trigonometric function. Let's come to another sign, that is sign. So sign is nothing but your signature, right? So sign. So whenever you're asked to sign a document, your eyes always goes to the corner. I mean to the below, right? So whenever you will be given any document to be signed, most of the times it will be signing below, right? So there you can remember that sign. You are going so sign sin, this sign and sign. These two are what? Homophones. So you can remember that whenever a document is given to you, you always look down for signing, right? So it's a usual thing that's a human psychology. Usually signing always comes below, right? Most of the cases. So that's how we are going to remember for sine theta. So for sine sin, I'm going to remember homophone sign, which is signing below, right? So then you can easily say that sine theta is for root of fingers below by 2. This is a simple trick for sine, right? Very simple. You can easily do it without any confusions. So now let's find the trick for cos theta. So for cos theta, it's the opposite of sin theta, that's all. For cos theta, what you're going to do is root of fingers above by 2. So you're going to consider the root of fingers above here. In sin, you used to consider the root of fingers below. Now it's nothing but opposite of sin theta, that is you're going to consider the root of fingers above by 2. So suppose we have to find cos 30 degree. So 30 degree, where does it come? So 30 degrees is our middle finger. So you're going to close this middle finger. So what's left now? Fingers above you have to see. For cos, you have to look for the fingers above. So that is, so above my 30 degree, I'm having 3 fingers. So it's root 3 by 2. So this is my value for cos 30 degree. Now, without looking at that picture again, using your own fingers, using our own fingers, we're going to find out the value for cos 90 degree. So cos 90 degree, for cos 90 degree, our thumb finger is 90 degree. Close that thumb finger, close that 90 degree. So what are the fingers left? Above 90 degree, is there any fingers left? No. So what's our answer? Root 0 by 2, that's nothing but 0. So here we go, cos 90 is 0. So this is a very simple trick that can be used. For sine, it's root of fingers above by 2. For sine, it's root of fingers below by 2. And for cos, it's root of fingers above by 2. Next, for sine and cos, that is the trick you're going to follow. For tan theta, here we are going to make a slight change. That's nothing but we are going to just flip our hand. So previously for our sine and cos, our left palm used to be facing us, right? So now we are going to just flip it backwards like that. And the theta remain the same, only you're going to flip the hand. You're going to just flip your hand. The theta is going to remain the same. For little finger it's 0, ring it's 30, middle finger it's 45 degree, index finger it's 90 degree, and our thumb finger index finger 60 degree, and our thumb finger 90 degree. They all remain the same. We're going to just flip our hand, that's all. And here for tan theta, it's root of fingers above by root of fingers below. So above and below. So for this, how do you remember the trick? It's nothing but root of fingers below. Below is our denominator. So we are going to place that root of fingers below in our denominator, root of fingers above in our numerator. That's all. The name itself, the trick itself suggests which has to come above and which has to come below. So let's start. It isn't that complicated. So let's start. So for tan 60 degree, let us take for tan 60 degree. So for tan 60 degree, what we are going to do is tan 60, as usual, you are going to close your 60 degree. That's your index finger. So how many fingers we are having above? 3, right? 3 fingers. So root 3 by how many fingers you are having below? Only 1. So root 3 by root 1, it gives us what? Root 3. So this is our tan theta. So tan 60 is what? My root 3. Right? Now next, let's take for tan 30 degree now. So for tan 30 degree, it's the same trick again, root of fingers above by root of fingers below. Right? So tan 30 degree, for tan 30 degree, you're going to close your ring finger. How many fingers you're having above? 1. So root 1 by how many fingers you're having below? 3. So root 3. Root 1 by root 3 is 1 by root 3. And you can see tan 30 is our 1 by root 3. So this is a very simple trick that can be used for tan theta also. Fine. And rest of the thetas can be checked in the same way. It's very easy. You can try it on yourself now. Fine. Next, coming to trigonometric hexagon. So we know for tan, cos and sine. Now what about the secant, cosecant and cot? Still 3 more functions are remaining. 3 more trigonometric functions are remaining. So how do you find them? So here For that case, we are having a trigonometric hexagon. So here, for our sine theta, it's our cosecant theta. So you are going to consider the reciprocal, that's all, reciprocal of that. So for sine theta, this is my sine theta, reciprocal of sine is cosecant theta, right? For cos theta, the reciprocal of cos theta is my secant theta, right? So for sine it is cosecant, for cos it is secant. And for tan theta, what's my reciprocal? Cot theta. So for if you remember this, you're going to just do the reciprocal of this. So sine theta, we are having sine theta, right? So what's my sine 30 degree? It's 1 by 2, right? So what is my cosecant 30 degree? It's sorry, just a minute. Yeah. So for sine 30 degree, it's 1 by 2, right? 1 by 2, we know the value of it. So for cosecant, it would be 2. That's all. You're going to just take the reciprocal of it. Using this trigonometric hexagon, you can find the reciprocal. So for sine, it is cosecant. So reciprocals you have to remember. Sine reciprocal is cosecant, cos reciprocal is secant, tan reciprocal is cot. So if you remember this trigonometric hexagon, you are going to just reciprocal the values. For sine it's 1 by 2. Now it becomes, in cosecant it becomes 2. Similarly for all the for all the other values we are going to take. And another important point which we have to notice here is, for sine 0 degree my value is 0, right? In cosecant it becomes not defined. Why? Because 0 by 1 is 0, but 1 by 0 it's not defined, because we can divide 0 by any number, but 0 cannot divide any number. It's a basic mathematical rule. It's a basic mathematical principle which we would be studying from our very lower classes. So reciprocal of 0 is always not defined. This has to be noted. This point is very, very important. Here most of us will make a mistake. And the reciprocal of 1 is 1. Reciprocal of 0 is not defined. Reciprocal of not defined is 0. Because not defined is what? 1 by 0. When you take the reciprocal of it, you get 0 by 1. So 0 by 1 is defined, that is 0. It has a value that is 0. So reciprocal of not defined is 0, and reciprocal of 0 is not defined. Reciprocal of 1 is 1. Fine. So these are the points to be noted whenever you find your trigonometric values using these tricks, and these tricks are very helpful. Hope everyone understood this. Thank you so much for watching, and subscribe our channel for such more updates and tricks.